And the final thing for today, I wanted to talk a little bit about analyzing massive batteries of runs. See, once we stepped into this shaky road of generating multiple batteries of runs, sooner or later you discover that it's very easy to generate hundreds and thousands of runs. But then the question is, what do you do with it? Well, the simplest thing to do, of course, is to simply pick the top performer, or pick the smallest model, or pick that, or pick that. But apparently, you can take that information and further post-process it using, say, TreeNet itself. And I find it personally fascinating because first, you say you generate thousands of individual TreeNet runs. And then you use TreeNet itself to study its own results in one big super run. Now, let me clarify exactly what's happening here. We have a kind of interesting illustration here. There was an interesting client application. So what we got is to say, I mean, think about it, say, hypothetically, some kind of online marketing campaigns. So each day, you're running different campaigns. So you have a kind of non-stop operation, 7 consecutive daily data sets originally available to study day of the week effect. So you have seven data sets, very large data sets, one per each day, Monday, Tuesday, Wednesday, Thursday, etc. Now, we partition the data set into a validation sample, so the fixed amount is extracted randomly and set aside. So you have 7 validation samples, 1 per day. Now, the remaining part of the data, and it was a huge kind of rare response model, so you have lots of zeros and a small fraction of ones. I don't have time to discuss the topic today, but we found out a long time ago that you may benefit from sampling or downsampling the zero part dramatically while keeping the rare part intact. So what we do here, we say, let's grab learned samples with different sampling rates. So let's pick basically 6 different sampling rates. Let's take 50% of ones, 20% of ones, 10%, 5%. So it's 6 different sampling strategies. And that gives us what? 7 days. On each day, we have 6 possible learned samples. That's already 42 cart models in that specific application. And then each model is, in turn, applied to our validation samples. So what we're doing here, we're saying, take the model on Wednesday. That was built on a sample with only 20% of zeros, and apply it to every day of the week, forward and backward, including that same day. But each time you have validation sample. So altogether, now you have 294 performance scores. So each scoring round produces its own accuracy. And each scoring round is characterized by 3 descriptive dimensions: day of week, sampling rate, and there's basically, day of week and the sampling rate. And also the day that the model, well, you see, the day of week kind of forks into 2 separate components. The day that the model was built versus the day the model was applied. Each record described by these. So now you can picture a set of 294 performance scores. The target is the performance. But each situation is described by its own combination of 3 variables. I take TreeNet. My performance is the target. These 3 variables are my predictors. I run it in TreeNet, and I can extract what happens to my performance when I have these times that the model is built, times that the model has been applied, and also the sampling rate. And in particularly, the interesting part about the sampling rate is that when I sample more, I'm kind of getting a better performance. Well, ultimately, in this particular run, we went to 3D plots when you're studying the joint variation in terms of, say, the time the model was built, and the time the model was applied. Or there's another graph here when you see the sampling rate, and the small number shows it's like 10% sampling rate, 5%, 4, 3, 2, 1% sampling rate. If you look carefully at this dimension, you'll see that the model performance goes up as the sampling rate is reduced. So in this particular application, it was very beneficial to sample dramatically, downsample zeros. And you can also see that it sort of persists over these different days and the different times to build and the different times to apply. Well, I could go over it at kind of even more, could discuss various issues here, but hopefully it illustrates the general point of how you could generate massive design with a whole bunch of things changing, and then assemble all those results into one performance data set and run TreeNet again to extract information, the summary information describing what happened as part of that design. And it's very powerful. And you don't have to go as fancy as that. It could be as simple as running TreeNet models and varying sampling rates, learn rates, tree size, everything, and then one final run that summarizes it all. And you'll see that the certain aspects of it emerge. And the reason I like it also is that it eliminates, I mean, we have these different data sets, different times, different day of week, but you kind of see that with respect to the rate, the pattern sort of replicates itself. Otherwise, it's always quite dangerous to rely on one specific model instance to claim that you have a better performance than something else. Whenever we have a replication, whenever we have multiple models run under a variety of different circumstances, then a lot of these factors will become more transparent and more